Hi guys, it's Miss Lauterbach. So what I'm going to do is I'm going to walk you through how to draw a Bohr's model of an ion. Now, just a reminder that an ion is an atom that has either lost or gained electrons. So as we go through and draw these Bohr models, the only thing that's going to be changing are the electrons. The protons and the neutrons will stay the same. And the whole point of this exchange of electrons is so that the atoms look like a noble gas. So each of our drawings will resemble a noble gas at the end. So here we have a hydrogen with a -1 charge. Okay, that's going to form what we call an anion. So it's going to gain an electron. Now in a normal atom of hydrogen, it has 1 proton, 0 neutrons, and 1 electron. So that hydrogen atom, okay, a traditional hydrogen atom, its protons and neutrons, they cancel each other out. It's a neutral particle. Well, in this case, we have an anion, so it's going to gain an electron. When it gains an electron, our new hydrogen anion is going to look like a helium atom. It has 2 electrons in its outermost shell. It will now have a charge of a -1. Going to show that 2 electrons. And it's now considered filled. Now over here we have our hydrogen again, but it's a +1 charge. So this is what's going to form a cation. In this case, it's going to lose an electron and become more positive. So our proton counts stay the same, which is 1. Our neutrons will stay the same. But originally we had 1 electron of hydrogen. Our little hydrogen atom here had an electron. But what happens in a cation is it's going to lose that electron. So this electron is going to leave the atom. And when it does that, when it leaves the atom, our electron count changes to 0. So our new hydrogen atom doesn't really resemble noble gas at all. It just doesn't have any electrons in it, and it has a +1 oxidation charge. Lithium. This lithium has a +1 charge. It too will form a cation. It's a metal. Now lithium's atomic number is 3, so it'll have 3 protons, 4 neutrons. That will stay the same as you traditionally find it. A normal atom of lithium has 3 electrons. So when I draw my lithium atom, it has 2 electrons in the first orbital and a 3rd electron in the second orbital. That 3rd electron is going to leave the atom. When it leaves the atom, your electron count changes to have 2 electrons in its outer shell. So it's going to look like helium. So when I draw my new atom, it has the 2 electrons in the outermost shell with a +1 charge. Here I have a beryllium ion. It too is a metal. It'll form a cation. Beryllium has the atomic number of 4, a neutron of 5, and a normal atom, neutral, of beryllium has 4 electrons. So my protons and my electrons, they cancel each other out. So beryllium, 2 electrons in the first orbital, 2 electrons in the second orbital. Because it's a cation, it's going to lose electrons. So it's going to leave the atom. In this case, it's leaving 2 of the electrons. So that's going to change my count here of electrons to 2. So I have 4 positive protons and 2 negative electrons. So my new atom of beryllium is going to look like helium. It's only going to have 2 electrons in its outermost ring, and it will have a +2 charge. So you notice the oxidation number is the same. All right, fluorine. Fluorine is a non-metal. It's going to gain an electron, so it's going to be an anion. The atomic number of fluorine is 9, so it'll have 9 protons, 10 neutrons, and 9 electrons. So this is, again, a neutral atom of fluorine. So when you normally draw fluorine, you have 2 electrons in the first orbital and 7 electrons in the second orbital. It's going to gain an electron. When it gains an electron, the atom becomes more negative. You're gaining a negative subatomic particle. So our new atom of fluorine ends up looking like an atom of neon. It has a filled shell. It meets the octet rule. And because it gained a negative charge, it becomes a -1 oxidation number. Okay, last one is oxygen. Oxygen has the atomic number 8. All right, it's going to have 8 protons, 8 neutrons, and 8 electrons. It has a -2 charge and is a nonmetal, so it'll form an anion. When I draw my oxygen, it'll have 2 electrons in the first orbital and 6 electrons in the second orbital. It's going to gain 2 electrons, meaning it's going to gain 2 negative subatomic particles, making it a 10 now. When it does that, that oxygen now looks like neon. And it's gained 2 negative electrons. Now there's a couple ways to double check yourselves as you work on the problems in the back. Your outer shells should be filled when you add the oxidation numbers or lose the oxidation numbers. Your number of electrons should always equal a noble gas. So the number of electrons here, 2, resembles helium, and my drawing resembles helium, even though I've drawn beryllium. But just as an example for you, a reminder, helium has 2 protons, 2 neutrons. It's filled. So it looks like a helium atom, except this beryllium lost electron that's got a charge. Same with my fluorine here. It's gained 2 electrons. It has a filled shell. It looks like neon. And neon has 10 electrons. So it's a good way to double check yourself. All right, good luck with your practice on the back side.